Hi class, and welcome to Chemical and Physical Investigations. I'm Jessica, and today we have Francisco, Leslie, and Brenna. Today our lesson is for 5th graders who are in physical sciences. Our standard is conduct an investigation to determine whether the mixing of two or more substances result in a new substance. Have you ever been curious to know what happens to a substance when you mix it with another substance? Use fire to add heat or add it in a liquid? Then you might wonder if the changes that you are seeing are either physical or chemical. If the reaction is a chemical reaction, does this mean a new substance was formed? Let's find out.
Hello, my name is Brenna, and we're going to be going over the objectives now. So, students will be able to determine whether a reaction is either a chemical or physical reaction. They'll be able to define the characteristics that lead them to believe that the experiment proved to be chemical or physical. So the students will be doing 3 different experiments to see if mixing one substance with another or adding heat will create a new substance or just change the appearance to determine whether the reaction was chemical or physical. Alrighty, now so on to the procedures. The students will be divided into multiple equal groups, and it really depends on the class size and amount of materials. They're going to measure out the amount of materials needed for each of the experiments, and the amounts needed should be listed on the board. They're going to record in their lab notebooks how long it took for each of the changes to happen. They'll also record what ended up being the result of the mixture or heat, so like color change, texture change, or any new substances that they saw.
Hi, my name is Leslie Gordo, and for this lesson plan, the amount of materials will vary depending on your class size. We'll be doing 3 experiments. In experiment 1, you will need bowls, cereal, milk, and measuring cups. For experiment 2, you will need empty water bottles, balloons, vinegar, baking soda, funnels, and spoons. For experiment 3, you will need a pan, eggs, cooking spray, stove, spatula, and plates.
Hey guys, so for the experiment 1, it's quite simple actually. You can see here all you need is a half a cup of milk and a half a cup of cereal, and once you have that, you put them together. All I say is just be careful not to spill the milk like I did. As you can see in the video, there's no color change, texture, and I can't smell anything different. So we can see this is a physical change. Also mean there's no new substance was made. Another point we can say is that if we did give the students a filter, they can separate the 2 substances, also proving it's a physical change.
Hello, my name is Francisco, and today I will be conducting a reaction by mixing vinegar and baking soda. The purpose of this lab is to demonstrate whether this is a physical or a chemical reaction and why it proves to be that way. So, for this lab, we will be needing a bottle, a funnel, a balloon of some sort, a spoon, and of course, baking soda and vinegar. So, in order to begin this lab, we will be using the bottle, and we're going to fill about, I would say, a third of the bottle with vinegar. So let's do so right now. I would say that's fine. So we have our vinegar in the bottle. And now using our funnel, we'll be pouring a spoonful of baking soda into the balloon. So make sure it's inserted all the way. Just make sure that all the baking soda gets in there. Leave that there. So with the spoon, grab the baking soda. Oops, right there. I'm right-handed, I don't know why I use my left. So pour that in there. Make sure it's all in there, nice and secure. Remove the funnel, and without getting any of the baking soda into the bottle just yet, try and get the balloon wrapped all the way around the lid of the bottle. Make sure it's nice and secure so that it doesn't spew out. So you see how it's nice and tight on there? All right, and now we will just grab the balloon and expand this just a bit. We're gonna grab the balloon and get all the baking soda into the vinegar and see what happens. So 3, 2, 1. That in there. Alright, so what we see is not only is the vinegar reacting with the baking soda by bubbling up and rising, but it also inflated the balloon by creating a gas. So we can conclude that this indeed is actually a chemical reaction because a gas was produced by a solid and a liquid. And that's it for my experiment. Thank you for watching.
So for experiment 3, we will be needing a stove, a pan, cooking spray so the egg won't stick to the pan, a spatula, and a plate to put the fried egg.
So the first thing we're going to want to do is spray the pan with some cooking oil so the egg doesn't stick. Then we take the egg and crack it open right on top of the pan. Now we can set aside the shell and watch as the reaction takes place. If we get a closer look, we can notice that the egg changed from more of a clear color to a white color. Also, if you can see, there are bubbles forming, and bubbles are a good indicator of a chemical reaction. On top of that, the liquidy egg white turned into more of a solid egg white. And if you cook it long enough, browning even occurs. So if we watch, we can see the egg slowly getting harder. So now that the egg is solid enough to flip, we can flip it, let it cook just for a little bit on the other side. Okay, now I think it's ready to put it on the plate for further inspection. It's looking good.
As you can see, this is a result of chemical reaction. We applied heat to a raw egg, and we can see that it changed in size, shape, texture, and color. Its size, it got bigger. In shape, it extended. In texture, it went from a liquid to a solid. And in color, it went from transparent to white. We can also see that when heat was applied during the cooking process, there was bubbles, which is a good indicator of chemical change. And you know that this is chemical change when you cannot put it back into its original form.
So now we're going to attempt to put the egg back in its shell to show you that this chemical change cannot be reversed. It's an irreversible chemical change. As you can see, it's not returning back into its original form of being raw, so therefore it's definitely irreversible.
Hello, my name is Francisco, and I will be reading the conclusion. Students should be able to perform these experiments with a fine success rate. The questions they answered should be turned into the instructor to make sure the lab was a success for each student. By conducting these experiments, students should be able to get a more hands-on approach towards learning what is physical and a chemical changes and how it looks in everyday life. These experiments should give students an understanding of the possibilities that may happen when mixing two or more substances, and how by observing what happens when they mix, they can identify what is specifically happening in the process. By answering questions during the experiments, students should be able to adapt what they learn while performing the experiments. Instructors should know if the students are on the right path by A, correctly identifying the type of reaction that is happening in the specific experiment, B, apply what they observe while performing these experiments by giving detailed explanations, and C, successfully execute the experiment by having a similar result to what the lab was asking for. Thank you.